Hello, this is Shakil Ahmed. In this tutorial, we will discuss about generalized linear mixed effect models. In previous video, we discussed linear mixed effect models, which includes both the fixed term and the random term, that is called the random effect and the fixed effect. Basically, random effect captures the variability between clusters or within different uh, specific classes, or when we have repeated observations we use uh, that variability within group into model in terms of a random intercept, that is called a random effect. So the linear mixed model assumes that the continuous variable, we have a dependent continuous variable, and that is related to different factors that include two continuous and categorical variables. But the dependent variable is on continuous scale, and we assume that there is a linear relationship between x and y. But the generalized linear mixed effect models just combines the uh, properties of the linear mixed effect model and the generalized linear model. Generalized linear model means we have dependent variable with categorical variable or some discrete variable or some count variable, we just have a binomial link function that basically models the probability of having a category or probability of falling into a category on the axis. That is called a binomial link function. And in Poisson link function, we model the mean of the counts, basically average number of events on axis. So basically, we are combining the generalized linear model to a linear mixed effect model, that is called generalized linear mixed effect models. So this is we used when we have clustering structure, or when we have longitudinal data with repeated mails, and as well as we have a non-continuous categorical or count outcomes. So let's see. Uh, we have again taken the data for heart disease, which includes, I have just run here. You can see the age, sex, blood CP, and test to blood pressure, and other variables on the target is basically the disease status, whether the patient has a heart disease or not. So we have a categorical response variable, and we have all other covariates. And for example, the helium group, basically that is related to the blood uh, concentration level, that is called helium. We have different groups of helium, one, two, three, and including zero, I think. So we just take this variable as our grouping variable, that is called clustering variable. For example, if we have same patient data on same patient for multiple time period, then this will be a time variable. For example, one, two, three, the data on patient one at time one, patient one, time two, patient one, time three. So this can be considered as a time variable. So in this case, we are just taking this as grouping variable, and we have other covariates, age, sex, CP, and cholesterol level. So we first see how the target variable and the covariates are linked, and they are different across different groups. So we are just plotting XY plot target, that is our response variable, and the predictor are the exposure, and then we have the grouping variable. So and the data is DF, and type of the line, that is we are plotting points, and this is grouping variable. Uh, so we can just plot it. Here you can see we have four different values. Uh, Values are not mentioned. Even you can give the grouping values here. For this is for group 0. I think this is group for 1. This is group 2. This is group 3. Uh, so there are different patterns between age and response for different groups. So we can just see a relationship between the response across the groups. So we have different pattern of responses, a relationship between age and target for different groups. So this plot is appropriate when we have continuous response, although but I have just shown how we can plot the relationship between x and y for different levels of the grouping variable. And now we are going to run a generalized linear mixed effect model that is under package LME4, and we are just writing GLMER, that is generalized linear mixed effect model with target, that is heart disease status, and the age, sex, and other variables are taken as the independent variables, and this is the grouping variable thelium group. And the data is data frame, that is on here, and the family is binomial. It means we are applying a logistic regression with binomial link, and you can just run it and summarize the result. This will produce the same result as the linear mixed effect model with the scaled residual values, minimum binomial statistics for scaled residuals, standardized residuals, and then the grouping variability for the variance for the grouping variable, that is uh, 0.556, and with standard deviation this, and number of observation is this, and we have four groups, and these are the fixed effects of different variables on uh, heart disease status. We can see age is negatively impacting the heart disease. It means the risk of heart disease will decrease with increase in age. Although this is not correct, but we can uh, see why this result is showing. There may be some confounding effect of other factors. That's why it's causing showing a negative result. And sex is also negative, and it means we have higher heart disease in females, males as compared to females, and this is CP. This is positive, and this is also negative. So most of the variables are significant when we run a mixed effect model, taking the uh, thelium level as grouping variable. When there is no clustering, we can still use the generalized linear mixed effect model, taking the individual observation as the group. For example, if you have no observation, then you can just take either the individual observations, the ID, for example, as the grouping variable, that will still give the uh, result, but the result will be the same as we get through a linear mixed effect model. Sorry, generalized linear model, not a mixed effect model. Basically, the random effect will be vanished when we have no grouping. And we can just check it. I'm just creating an observation variable with name observation, that is 1 to n, for I as id just, and we can see that it will be 1 to 1000. And we are running a generalized linear mixed model using observation with thallium group, and that is another grouping variable. So this will provide the same result as the previous uh, model, and you can compare the two models, GLLM1 and GLMM2. You can just check. uh, we can see that there is no significant difference between the AICs, BICs. There is a slight difference in BIC due to number of uh, groups increased and due to loss of degree of freedom, and uh, the log likelihood is same and deviance is also same, and the two models are equal as the p-value is 0.99, almost 1. And if we just remove the grouping variable, and we can run it and compare with the original model, we are just taking uh, individual observations as the group. It means we are just running a generalized linear model, not a mixed effect model. So again, we comparing this result with the original GLMM one. So there is a significant difference, and the model is much improved when we use. You can see the AIC value is small, BIC value is small, and likelihood value is also small, and deviance is also small when we use the grouping variable. Basically, we are including a random effect in the model. It improves the result. So that's why we should incorporate the grouping variable when the observations within groups are or highly correlated with each other. For example, if we have repeated mayors, the observations within for an individual person will be highly related to each other. For example, we are measuring blood pressure of a patient 3 times, 4 times, then those observations will be related to each other. And incorporating this information will increase the accuracy of your model. Uh, and uh, it is performing better than a simple generalized linear model. And uh, this will provide this same result with the simple logistic regression, as we are using the individual observation as the grouping variable. So you can compare with the this is the result for GLM, generalized linear model with family binomial. It means uh, we are running a logistic regression with binomial link function, and now we can compare the results of GLM3, that is individual observation is taken as group, and GLM where the thallium level is taken as the grouping variable, and GLM0 means we are just using a logistic regression. So you can see the performance is uh, better for the model when we have uh, when we have when we included the random effect in the model is much improved for all measures, including AIC, BIC, and log likelihood, deviance, and the chi-square p-value is significant. So we should always be careful when there is a grouping effect and the observations within groups are highly correlated with each other. Then we should take care of it, and we should incorporate the random effect in our model. In next video, we will discuss generalized linear mixed effect model using Poisson link function and negative animal link function when we have discrete variables. Thank you for watching, and don't forget to subscribe the channel if you have still not yet subscribed.